If you want to know why 3D printing did not deliver on its promises, this video is for you. I'm going to explain you, and we're going to go through why is 3D printing not to the level that we expected. One of the biggest problems is strength. How can we bring more strength into 3D printed part? So let's start.
So at the beginning, you have the hype. Everybody gets excited about the technology. Then there's a moment where there's a lot of deception. In 3D printing, it's usually people buying a very low-cost 3D printer and expecting result of a 3D printer that costs many millions of dollars. And then slowly, the technology finds its place, and then you can reach the plateau of productivity. So in 3D printing, we had this stage where we are moving from prototyping towards actual product. And this happens application by application. Find the key elements that are missing to be able to make that transition.
So we are going to focus on FDM, fused deposition modeling. This technology is the most popular one because of this low entry point. And we are going to look into what's the real issue here. Why can't we get away from making prototypes and really be able to make products with this technology? Let's look at why.
In FDM, you're creating parts layer by layer, but you're making these beads that you deposit. And even so, the parts are extremely close to injection molding on the XY direction, you end up with a very weak Z-axis bonding. So it means that you have a limited structural integrity on the part, and they fail usually through the layers. You will, if you stress a FDM printed part, you will usually break it through the layer. There's also a porosity issue because the beads, when you print, they're not perfect. I mean, they're not square. They are more like round, and then that leaves some gaps between the beads. And at the end, you end up with a part that is not isotropic, and you have an inefficient load distribution.
So now that we know the problem, how can we do that differently? How can we improve? Well, think about it. Every time we print, we make layer by layer. That's the core issue here, is that those layers need to be stronger. So let's look at the big idea from ADDCAAM.
So really the idea of the Interlace technology here, if you take a look at this red line, this is representing, your shear path of the fracture through the part. If you look at the blue arrows, see that this is kind of like a free body diagram of the forces that we're putting on the part in sort of a shear type scenario, right? Now, most of your FDM parts, they're going to have less than 20% strength in the Z direction of the parent material. Breaking along that XY plane, makes these parts very weak.
So that's a pretty cool idea, but going from that idea to actually implement it somewhere, that's pretty difficult. Let's look on how the team has been working on different parts of the technology and managed to solve one issue at a time to bring this technology to market.
So really the big idea here is to increase the strength of the parts through software. A lot of developments have been done through a lot of different companies to increase the strength of materials. You might get like maybe increase 5-10%, printer technology can also increase the strength of parts. But really where all these FDM parts fall short is in the way that you actually build the parts. So by optimizing the tool path is really how you're going to increase the strength of the parts more than anything else. So there's really two main features in the software that we use to increase the strength of the parts. So the first one's the Interlace technology, and this is where we use the shifted layers to basically stack the beads in such a way to where whenever the part fractures, the force isn't distributed through a straight line through that XY plane. It has to travel and bend all over the place. So that really increases the strength of the part. Not only that, by stacking the beads in the way that we do, we're greatly reducing the amount of porosity in these parts as well, which of course also increases the strength of the parts.
So it's a great technical solution, but how to bring it to market? It's really difficult when you have a lot of intellectual properties in the game. How do you make that normal people can have access to it? So we've worked closely with ADDMAN engineering to be able to integrate this into our software as a plugin, because then it's much easier for us to clear all IP rights.
We've done a lot of testing on all these parts in a bunch of different ways, and we found that actually the strength of these parts is increased in every scenario, shear strength, tensile strength, and fracture strength. One interesting thing that we found out was that this overflow is sort of required with these parts. So essentially, you're increasing the amount of material that you extrude in these parts because the way that we lay down the beads, we're filling in more of those gaps. So essentially, you know, we have to extrude more material in the same amount of volume as a traditional print. So it's going to make a denser part and a part with much less porosity. If you take a look at these arrows here, you'll see the interlace contour that's sort of pointing to the bead stacking method that we use. And this is sort of like the outside of the part, right? Your shell or your walls, as we could say. And then also we've got the interlocking infill where, you know, we're making that extra wall every other layer.
So it's a great technical solution, and ADDMAN Engineering has been using it for years. We've made it available through a slicer. But how to make sure that other people, that you can get it and that you can use it? That's pretty difficult because there's a lot of intellectual property rights that we needed to resolve. So we came with the idea of making a plugin that will then work into one of our commercial products, REALvision Pro. And ADDMAN Engineering was okay with this, and we managed to make a great agreement so that we can bring it to the people. So now I'm going to basically show you a little bit more about that product that you can have for yourself.
So I'll tell you a little bit about REALvision Pro. We have a slicer called REALvision Pro that is basically state-of-the-art into slicing technology. We've been developing core features for the last 15 years, and it's really state-of-the-art. And we have the ability to bring other capabilities through plugins. So that's what we've done for ADDCAAM.
Now I'm going to show you how to slice using ADDCAAM. So in REALvision Pro, you can open an object, and by default, the ADDCAAM plugin will not be enabled. So if you slice the object, hitting the prepare button, you will see a normal way of slicing. So the beads will be in the same plane. So if I zoom here, you can see that those are aligned. Now, how to enable the ADDCAAM plugin? Well, you go back to the normal view. In the main view, on the top right, you will see your plugin icons, and one of them is the ADDCAAM plugin. So when you click on this, you will now see ADDCAAM plugin and slice with ADDCAAM. This you can toggle on and off. So it means you can turn on your ADDCAAM plugin and now hit the prepare button to reslice using ADDCAAM. When you slice using ADDCAAM, now you will see that on the cross section, the beads are now using the ADDCAAM plugin. So you have shifted beads in the contour and also in the infill. You can also turn it off again by just clicking the toggle button.
Go to REALvision Pro and $20, so $19.90, you can actually get the slicer and the ADDCAAM plugin. This includes 2 seats, so it's a single user license with 2 seats, cover everything that is in the slicer plan, and has all the feature that we have described into this presentation. Right now, you can actually use it 14 days completely free, and we invite you to go and try for yourself on the website of REALvision Pro.
We are very excited about this new product, and we are looking forward for you to try it. So don't hesitate, go to our REALvision Pro website and download it and try it for yourself.